I had questions the other day about the definitions of the peak-to-peak voltage versus the amplitude voltage of waveforms as defined by oscilloscope manufacturers. I did some digging in documentation and have learned something, so I thought I'd post the answer to the questions that I posted the other day. In a traditional sense, for a sine wave, the amplitude is defined as half of the peak-to-peak voltage. But the oscilloscope manufacturers define it differently. And that's because we have some unusual waveforms with ringing potentially, and like a waveform we're looking at on the screen right now. And these red lines are indicating the peak-to-peak voltage as displayed on this measurement right here. So the peak-to-peak voltage is obviously the difference between the maximum voltage seen in a waveform and the minimum voltage seen in the waveform. So that's obvious what the peak-to-peak is. If I click on the amplitude, you see there's something different here. The amplitude is actually defined as the difference between the top and the base. And I'll just expand this out a little bit. The top is right here. That's defined as, I guess, the equilibrium point of where the ringing stops in the waveform. And then the base is the equivalent at the bottom side. So after the ringing has stopped, you've got the base voltage established, and then the amplitude is the difference between the top and the base. So in the case of a sine wave, the top and the base and the peak to peak are essentially the same, and that's what was confusing me when I was looking at things like a sine wave on the scope, as well as within the signal generator, which uses the term amplitude to define the waveform, the magnitude of the waveform. And if you're defining a sine wave, that amplitude is the peak-to-peak voltage. So that's what I learned today. I thought I'd post this in case someone saw that other video and was curious about the answer. All right, thanks for watching.